Hello guys, welcome back. Um, in the part one of this video and then of this velocity versus time graph video, we did the velocity versus time graph of a constant velocity, right? That is v versus time graph, v versus time graph. Alright, we did constant velocity. Done. Now we have to do the constant acceleration. So how is the velocity versus time graph going to look like if the acceleration is constant? Okay, so as usual, let me just draw two axes first. Okay, primary axis is time, secondary axis is velocity. Okay, now as the condition states, the acceleration is constant. That is, there is acceleration. Okay, and for at this level, we always choose acceleration to be constant. All right. Okay, so now there is acceleration. So let me draw a diagram so as to understand what it actually means. So if I travel from A to B, okay, and in the earlier video I divided this whole journey into two parts, right, of each of 2 seconds. Okay, now the only change in here is from the previous example is gonna be this. In the previous example, we traveled 3 meters for each part, right? So 3 meters for the first part, 3 meters for the second, 3 meters for the third, right? Okay. But for this part, right, it's gonna be different. That is, let's say for the first part I travel 3 meters, then for the second part I travel 4 meters, third part I travel 5 meters. That is, in the first 2 seconds I travel 3 meters, then in the second 2 seconds I travel 4 meters, and in the last part, that is in the last 2 seconds, I travel 5 meters. So my velocity for the first part, that is my velocity for the first 2 seconds, is gonna be first part. Okay, it's gonna be 3 meters divided by 2 seconds. That is 3 by 2 meters per second. Now velocity for the second part is gonna be 4 meters divided by 2 seconds. That is, I travel 4 meters in these 2 seconds. So it's 4 by 2 meters per second. That is 2 meters per second. Now the velocity for the third part is gonna be 5 meters divided by 2 seconds. That is 5 by 2 meters per second. Okay. That, as you can see, 2 is greater than 3 by 2, right? 2 is greater than 3 by 2, and 5 by 2 is greater than 2. So initially my velocity was lesser, then it increased to 2, then it increased to 5 by 2. So you can see my velocity is going up, it's increasing with time. Okay. So velocity in here is not constant, unlike the previous video. Alright, in this case the velocity is not constant, it is increasing. Okay, but it is increasing with the constant finite rate. That's what we mean by acceleration being constant. That is, the velocity is changing, that is, the acceleration is present, but it's constant. That is, the velocity is changing with a same rate throughout the journey. So here the velocity is changing, so there is acceleration. So acceleration is positive as the velocity is increasing. If the velocity increases, the acceleration is positive. If the velocity decreases, the acceleration is negative. Why acceleration is negative? Because if the velocity is decreasing, my final velocity is gonna be less than the initial one. That means this quantity is gonna be less than this. So smaller quantity subtract, bigger quantity subtracted from small quantity is gonna give me a negative answer. So the acceleration is negative. And what's the physical significance of this? It actually physically means that if you are traveling in this direction with a certain velocity, right, and my velocity is decreasing, that means there's some opposing force. There is some opposition to me, and that is what is causing me to decrease the velocity, like friction. Or maybe if you're traveling in a car, then you suddenly apply brakes, all right, so your velocity is decreasing when you apply brakes. That is, brakes are providing that necessary opposition, the necessary resistance, that is the necessary negative acceleration, that is sometimes called deceleration, right? Okay, but in here the velocity is increasing, so the acceleration is gonna be positive. So the velocity is increasing. Okay, so the velocity is not gonna be constant, it's increasing, but it is increasing with a finite rate. So as we move on time axis, there is always gonna be a finite change in v-axis, and the change is always constant. For each change in time, there is always a certain finite change in v. Okay, so in essence, this graph is gonna look like this: a straight line. Why not a curved line? Because it is constant. The acceleration is constant. If the acceleration were not constant, then it would have been a curved line, either going up or going down. Alright. But as the acceleration is constant, so it's a straight line. It's always making a same angle. That is, the rate is same, and the rate, that is dv by dt, is constant. That is, acceleration is constant. That is, tan theta is constant. Okay, so it's just gonna be a straight line when the acceleration is constant. Okay guys, that's it for this video. I'll see you guys on the next. Okay, see you.